Hello and welcome to this video on mixed costs. Previously, we classified costs as either a fixed cost or a variable cost, but sometimes some costs a business face don't fall into one of these categories in a clear manner. These will be called mixed costs, and they're going to have characteristics of both fixed and variable costs. An example of a mixed cost would be when you lease a car. You may have a daily rate such as $200 a day, but you then may have to pay a per kilometre fee such as 10 cents per kilometre driven. This would be a mixed cost. Whether you use the car or not, you have to pay $200 a day. But then as your volume of production or activity levels increase, you have to pay that extra cost per use. Retail leases are often structured in this way. You may pay a rental fee such as $1,000 a month, but you may then also have to pay 10% of your gross revenue. So there's a fixed component. Even if you have no customers, you pay $1,000 a month. But then for every extra customer you get who buys your products and generates revenue, you have to pay a percentage of that as rent for the premises. Utility fees often are structured like this as well. You have to pay a fixed cost for having your electricity, gas, or water actually connected. Then you pay a usage fee on top of that. So when we graph a mixed cost, the figure will look like this. We have this intercept point here, so even if I've got zero activity, I still have a cost. That would be the fixed cost component. Even if I use no electricity for the month, I still have to pay the connection fee, so I've got a fixed cost. Then, as I use more electricity during the month, my cost goes up, so there's also a variable component. So the mixed cost graph here is combining the fixed cost graph, in that there is an intercept point where there are fixed costs at activity 0. We can see our fixed cost at the intercept point. And then the slope of the line is the variable cost. We can express mixed costs using this total cost function. So the total cost is equal to the fixed cost plus the variable cost times the quantity of products. The fixed cost here, if you remember back to your high school mathematics, is the intercept point. And the variable cost is the gradient or the slope of the line. So when we look at the mixed cost figure again, if for example, our mixed cost is a fixed cost of $10,000 plus $2 per unit, our intercept point here is 10,000, and that is the fixed cost component. And then the slope of the line or the gradient would be 2, which indicates that for every additional product we create, we have to pay $2 extra in variable costs. So the formula, the total cost, is equal to $10,000 fixed cost plus $2 times the quantity of production. If our business has mixed costs, it's really important that we try and decompose the mixed cost into the fixed cost and the variable cost component so that we can make better business decisions using this cost behavior information. We're going to use a statistical technique called a regression analysis, and the regression analysis is going to help us break up those costs from a mixed cost into the variable component and the fixed component. In simple terms, a regression analysis gets us to draw a line through data that has been plotted like this. So all these little dots of activity and cost data we've got here, then the regression will draw a line of best fit, capturing that total cost is equal to the fixed cost plus the slope of the line times the quantity produced. So let's do a regression. Here I've got some data from a pizza shop, and I've got each month the number of pizzas the pizza shop made and the overhead costs they incurred. So overhead costs are those non-direct costs, so not direct labor, not direct materials, but all the other costs. So it includes things like utilities. Every month we know how many pizzas were made and we know the cost. We could plot this onto a scatter plot and try and draw a line of best fit through it ourselves, or we can use a regression, which is doing this for us. In this case, we're going to use Microsoft Excel to run a regression, and I'll briefly explain what the regression output means and how it can be interpreted for us. So I've opened up Microsoft Excel, and I've got the data in column formatting here. So I've got the number of pizzas each month, and I've got the overhead cost incurred. I'm going to go into the ribbon up here and click Data. Then I'm going to go to Data Analysis, and I'm going to choose the regression option. The regression options have showed up here. Input Y range. The Y range is our total costs. So I'm going to select the total cost for each month. And the X range is going to be our activity level, the quantity. So the quantity of pizzas we've made each month. I'm going to click OK there. and our regression output pops up. I'm just going to format our regression output using the accounting number format here, just to get rid of some of the decimals for us. So what does this output mean? This is a statistical test called a regression, and it's provided some output for us. What we're trying to find out is, for our pizza store, for every pizza we make, how much additional variable cost is there? And what are our fixed costs from our overhead? So we've got our regression output here, and I'm going to go down to this term here. It says intercept. Remember when we looked at the mixed cost figure and we said the intercept point is our fixed cost. So the coefficient is 3,998. That will be our fixed cost. The intercept is the fixed cost. And then the x variable, that would be the slope of the line, or our variable cost. So the coefficient is $2.09. This is saying for every additional pizza we make, we have to pay an extra $2.09 in overhead for the business. There's a whole lot of other numbers here presented in our regression. Some key ones would be the R squared, or the adjusted R squared. And that's actually telling us that our model is predicting about 88% of the behavior. So our model's about 88% accurate. That's what the R squared, or the adjusted R squared, is telling us. Then we've got some statistical tests like the t-stat and p-values telling us if these values are statistically significant as well. And because they've got very high t-stats and the p-values are less than 0.01, it indicates these are very significant relationships. The model is powerful, it's predicting 88% of the behavior, and we've got a pretty decent idea that the fixed cost is close to 4,000, and then for every additional pizza we make, we pay about $2.09. So by being able to classify mixed costs into their variable and fixed components is really powerful, and it allows us to be able to classify all the different costs in our business into either fixed or variable components, which is going to then be used moving forward into making business decisions. Thank you.